Okay, so what I want you guys to do, go ahead and read the top of this page. Go ahead and read the top to familiarize yourself with the terminology. Top of the front of the piece of paper. As a reminder, guys, the front of the piece of paper has hole punches on the left. Front of pieces of paper usually has hole punches on the left. I see 4 of you with hole punches on the right. Just saying. Okay, go ahead and read the top, please. It's the one that says study guide. One of you may or may not be sleeping right now. So we have centroids. We're going to talk about centroids today, and we're going to talk about medians. Medians is a segment that joins the vertex of a triangle and the midpoint on the side opposite the vertex. In the picture down below, we have a median drawn in. We have one median drawn in. We know that it's a median because of 2 things. One, it goes through the vertex. The second part, it bisects these tally marks. It says that it bisects that other side. Go ahead and draw in a second median and a third median into the picture. Draw 2 more medians in the picture. Okay, and make sure, beyond a shadow of doubt, we know that they're medians based off of the markings. Go. On that picture right there. Yeah. Draw the other 2 medians of that triangle. All right. Other median goes from C to halfway through. That is not a straight line. Guys. And how do we know it's a median? Well, it goes through the vertex and that's bisected. Okay? That would be a median. The third median, if we drop it straight, almost straight down, would go through E, the vertex, and perpendicular or bisect the opposite side, and we know that it bisects the side after we make those tally marks to say, hey, I mean it to bisect the other side. Those 3 segments all intersect at one point that we call the centroid. Okay? Fascinating. That centroid is the balance point, okay, of that triangle. So I'm going to write some stuff down here, some consequences of medians and their intersections. Okay? The medians, and I want you to write this down, the medians of a triangle intersect at the centroid. Oops, centroid starts with a C. My bad. At the centroid. The centroid separates the medians. Did I spell medians wrong? Feeling like I did. Yes, I did. Separates the medians into 2 parts with ratio 1 to 2. Can somebody tell me what it means to be ratio 1 to 2? That I think you'll understand. Sometimes when you're baking, like bread or cookies, and you get recipes, sometimes those recipes are in terms of the relative size of whatever you're using. And they'll say like 1 part sugar, 2 parts flour, right? They'll give you a ratio depending on how much you want to make, so you can make any amount. Okay, if I say 1 cup sugar or 1 part sugar and 2 cups flour or 2 parts flour, so a ratio of 1 part to 2 parts, how many total cups or parts am I going to put into the batter? If I do 1 cup sugar and 2 cups flour, how many total cups would go in this batter of cookies? 3 total cups, right? The ratio, though, would still be 1 part to 2 parts. Does that make sense? Okay, why is that even important in your world? Well, hypothetically, say you're making a balsamic vinaigrette. the ratio between the oil and the vinegar. It's a really good ratio when it's about 1 to 3. 1 part vinegar, 3 parts oil. Okay, just in case you're making a balsamic vinaigrette for your salad that you're about to make. Okay, throwing that out there hypothetically, and I put a little bit of honey in it, put a little bit of oregano, definitely throw some salt up in that action. Make it tasty. Okay, if it's too salty, throw some more vinegar in it. Too vinegary, throw some more salt in it. You know what I'm saying? It kind of balances each other. Anyway, next. So 1 to 2 is the ratio, and understanding that ratio is really important to understanding this whole conversation we're about to have. If the ratio is 1 to 2, that means there are 3 total parts that make up the whole. Does that make sense? One of those parts is the small one. It's half the size of the big one. Okay? In terms of the whole thing, the smallest is 1/3 the size of the whole thing. Does that make sense? If it's 1 part sugar, 2 parts flour, right? And I'm talking about the whole mixture of those. There's total 3 parts. The sugar is 1/3 the size of the whole mixture. Make sense? If that makes sense, this will make sense. If that doesn't make sense, this will not make any sense at all. Okay? I want to make sure. I didn't draw anything out or write anything out because we're going to write the geometry out while we're running out of time. So let's do number 2 first, 2, 3, and then we'll go back to 1. Okay? In terms of number 2, if EM in this picture is 3, what would EC be? Okay? EM would be would that be the small? Would that be the small? Would that be the big? Or would that be the whole? That would be the small. The small part is actually from the centroid to the side. Okay? The big part is the centroid to the vertex, which are words you don't really get. And the whole part is from the midpoint of the side to the vertex. Again, making it a little bit confusing. Okay? Small to big to the whole. So the big EC would be twice the size of that, so we would multiply it by 2. Does that make sense? And then if I had asked you what the whole thing is, you would have said it's 9, right? Because 3 plus 6 is 9. Okay. In terms of number 3, if EN in the picture, if EN is 12, what's AN? 12 is 1/3 the size of the whole. 12 times 3 is 36. Yeah, 36. AE would be 24. You could go to AE first and then just add those if you wanted. Okay? In terms of number 1, it gets a little bit trickier. 1, because there's fractions and you don't like that as much as you don't like the word ratio. But BP is 10. That is the whole part, right? In terms of the whole thing, 10, what is the small or the big section, BE? The big section, right? There's 3 total parts in this thing, right? 2 of those parts go to BE. 1 of those parts goes to EP. Okay? So it's 2/3 the size of the whole thing. In terms of making it a little bit simpler for you, if we talk about the ratio in terms of like variables, okay? If the whole thing is 3 parts, 3 times the whole, or 3 times W, give it some variable. If the whole is 10, and we want to find out what the small part or the medium part is, if we find out what W is, this one, we would just double it at the end, right? So in order to go from the whole thing to the small, we could do 10 divided by 3, right? To give us what W would be, that would be the small part. And in the terms of this, we want to know what the big piece is. It's twice the size of it. So it's 20/3. So BE is 20/3. Okay, let's go to the next one. Okay, let's label our picture to try to get an understanding of what where these need to be labeled. CM, that's our whole thing, right? So let's set it up in kind of our ratio setup here. 3x plus 6. That's our whole thing, right? Now, we want to find out what x is, which makes this a little hard. But we know what CE is. CE is x plus 12. Is that the big part or the small part? That would be the big part, right? We have the whole we're given the larger part, or the big part, we're going to call x plus 12. And we need to figure out what x is in the end. So we need to relate these in some way. There's a bunch of ways we can do it. Yeah. Yeah, you can pretty much find that by looking at it. The big part is always between the centroid and the vertex. So, okay. And you can pretty much always find that by looking at it. Okay. So the question is, how do we figure this out? We need to relate these three things, right? In terms of this problem, if you look at it, the whole thing, CM, is equal to EM plus EC. That make sense? EM is the small section, EC is the big section, and CM is the whole thing. You with me? So in terms of like an equation we can actually write, that, by the way, that's the segment addition theorem. But in terms of the equation we can write, we know what EC is. That was x plus 12. CM we knew was 3x plus 6. In order to do this, we have to figure out what expression for EM. To do that, we need to go back to what it means to be related in terms of the ratio. Okay, the small one is related. How is it related to the big one? Small one is 1/3 the size of the large one, right? That makes sense? So if we take the large one and we divide the whole one and we divide it by 3, we can get the small one, can't we? So what's 3x plus 6 divided by 3? X plus 2. And that'll give us an equation we can solve. Does that make sense? So we would get 2x plus 14 equals 3x plus 6. And then we can solve that and you get x is 8. And no, I did that fast. Okay. I'm going to answer this next one on the video. Your homework is to finish this whole thing. Okay, I'm going to keep talking through this, even though we're out of time. Okay? All right, in terms of EN now, so EN is the small segment, so x minus 5 would be the small segment. AE is the big segment, and we need the whole thing. And now for the whole segment, we got to figure out an expression for that. Well, the whole is 3 times the size of the small, so we're going to multiply that by 3. So we get 3x minus 15. And then we can write a relation expression for those. So using the segment addition theorem. And we go ahead and calculate this. We get 2x plus 12 equals 3x minus 15. And we get x equals 27 as our x. Well, we want to know what AN is, so how do we find out AN? We got to take that and put it into, we have an expression for AN. So we do 3 times 27 minus 15, and we get 66. All right, peace.